Hi, welcome to the E4 videocast series. I am Melody Craigmile. I am going to be going through some information about Almo Pro AV and our tour that we're having here today. So what is the E4 AV tour? Well, the first E is educate, and we are here to provide free quality education to the AV industry, and all of our courses here today, including the ones we're streaming live today, have CTS renewal units. Exploring products and solutions. Networking and exchanging ideas is a very important part of our program here. And finally, our expo. For our attendees that are here in Dallas today, they're getting to experience an expo with 35 manufacturers, the best in the industry, and we will be coming to you in the spring in Chicago and San Jose. So if you're in one of those areas, look for an announcement very shortly about our spring 2017 tour. And right now we're going to see a short video about Almo.
Almo is the nation's leading distributor of professional audio-video equipment.
So with our recent acquisition of IAVI, Almo Pro AV is now the largest distributor in our industry.
Anybody can supply a box, right? A box is just one thing. We want to supply a solution. So if you come looking for a digital signage requirement, we can help design it, we can do the content, and we can install it for you as well. So we don't just provide the box, we provide the full solution.
In addition, Almo is a great family, integrity, and team-oriented company, and that translates to the relationships that we offer to our dealers.
Infocom is the largest Pro AV trade show in North America, and it really gives us a chance to show the industry what we're all about.
Our customers choose Almo because of the relationships that our salespeople have and our team of highly specialized business development managers that can help them create complicated product solutions.
Our theme this year is Together We Grow, and this is really all about helping our resellers grow their businesses with new products, new solutions, and especially with our new services offering.
We help our customers grow their businesses. Together we grow. We have the technical resources available to be able to help them if they run into questions, if they're working on a system and need some assistance. We all know that in this industry it's impossible for one person to know everything. So we roll up our sleeves, get together our team, about a dozen business development managers, and really be able to make sure that we're able to help them grow.
It's my job here at Almo Pro AV to help those dealers understand the different facets of digital signage and what makes a successful deployment.
Well, it's about relationships. NMR events is about relationships, and I have really now friendships that I've had for these guys.
The reputation of the people that work for Almo is why I consistently use them.
They've always addressed our needs, and they go, like I said, above and beyond every time we need them.
Everybody is friendly, professional, and most of all, they respect what it is that we do.
We always need everything yesterday. Anytime I call them, I can get them anywhere.
The pricing's phenomenal. They help us to be able to make sure we can accomplish our objectives, working with our customers for product delivery.
So now we're reaching into Latin America also and other parts of the world. So we're not only a national company, we're also an international company now, which is really great.
Almo's the only distributor that I use. Plain and simple. I wouldn't use anybody else.
Great. So just a little bit more about Almo. We have a nationwide distribution network here, including a warehouse down here in the Texas area. And we encourage you to visit our website, which is almoproav.com, and you're going to find a wealth of information there. You can link to our blog, which our business development managers contribute to. It's fully responsive, so you can use it on your mobile site to get product information on the go. So visit us at almoproav.com. And also visit our website to learn about our new services. That's almoproav.com/services, and you can learn about our Almo Connect, our install, content, and our new control systems programming services. So just one question that we get often is, can I get a copy of today's presentations here at the E4 event? Yes, you can. So just go to e4avtour.com/on-demand, and there you can download copies of all of the presentations for today. We'll also be recording videos of some of the hottest products on the exhibit hall floor. So tune in there to see videos of the products, the presentations, and also some other news and blogs from the folks at Rave. So right now, for the folks watching online, you can send your questions into Gary Kay about his keynote address on Facebook. You can use the hashtag on Twitter, E4AVTour. So we will be monitoring that and addressing your questions at the end of Gary's session. And a special thanks to all of our manufacturing partners. And I do want to mention a special thank you to Barco for providing our 4K projection today. And just a reminder, all the products that you see on the exhibit hall floor and all the ones that you see in the videos online are provided, and we can supply those at Almo Pro AV. So without further ado, I'd like to welcome our keynote speaker, Gary Kay. Let's give him a round of applause.
That's perfect. Good morning, everyone. Thanks for coming this morning. You're in for something pretty special because, as you know, 4K has not been around very long. It's very new. Virtually no manufacturers are shipping 4K products, visual products yet, except in the consumer industry, but even the ones in the consumer industry have a lot of trade-offs. We'll talk about what those trade-offs are today. So what I'm going to do today is I'm going to talk to you about sort of everything you need to know to build systems in 4K resolution. And 4K is for more than just really pretty pictures, and that's one of the things I want to try to get across today, because you're going to use 4K resolution for things other than super high resolution images. There are other reasons to use 4K, and of course, as you know, virtually every projector or monitor manufacturer has launched a 4K device in the last 6 months, and all of them will start shipping this fall and early spring. So you're in time for a good presentation to learn the basics of 4K and how it's different from everything else you've seen so far. As Melody said, and thanks to Melody and Almo for allowing us to put this presentation on for you live, all this information that we're doing today with regard to this keynote, for example, is all available on our Facebook page at facebook.com/ravepubs. You can actually there's a number of people watching this live now, but you can also watch it delayed as well, because we're going to go ahead and repost this. And for those of you who are here live, in case you don't know, you can get Infocom CTS RU credits for this course. So just by sitting in this live, you get 1.5 hours of credit today. And for those of you who are watching online, you can get the same 1.5 RU credits by taking the test, which will be posted at the end of this presentation, immediately at the end of this presentation. It's 10 simple questions. It'll take you about 10 minutes to take the test, and as long as you pass the test, then you get the 1.5 hours of credit. So one thing that I want to point out here is that we are looking at one of the few 4K projectors that's actually available and is just beginning to ship, and this is by Barco, the HDX system. So what you're looking at here, and this may be for many of you who are here live, the first time you've ever seen a 4K projector in full 4K resolution. That's the reason why we use a screen this large, because we want you to see the difference in resolution and what you're used to in 1080p, because you are looking at something that is significantly higher resolution than what you've seen in the past. So this presentation is divided into 4 parts. The first part is sort of the evolution of resolution. The second part is beyond the hype, okay, because there's a lot of hype out there about 4K, and there's some specific things that you need to know about 4K signals that are going to make it a little tougher, I should say a lot tougher to route than HDMI. The 4K and Pro AV applications that go beyond resolution. And then, of course, I'll talk about something that's become really popular since we started this tour with Almo at the beginning of this year, which is the digital canvas concept that I came up with. So the first thing we should do is certainly address the evolution of resolution. How many of you have been in this industry for a while? How many of you have been in this industry for 10 years or longer? So you're familiar with all this nomenclature that's here on the screen, and it's probably a good idea for you to understand sort of how we got to where we are and why we are there. And the first thing I need to make sure we point out is some of the basic nomenclature and what things mean. because you've probably seen these terms thrown out here, 4K and UHD. But the problem is they don't mean the exact same thing, and it depends on how 4K is labeled as to what the different types of 4K are. Because unfortunately, just like we have done with the history of all of our stuff in the AV industry, we don't have one standard, we have a plethora of standards, so therefore you need to be aware of what the differences are between the different kinds of 4K signals. And it really comes down to two organizations, because those two organizations came up with different resolution standards. Now there's other issues in the standards besides resolution, which we're going to talk about today, but of course the most obvious thing that you're familiar with is resolution. So SMPTE, you've probably heard of SMPTE if you've been in the industry for a while, Society for Motion Picture and Television Engineers. They are the people that decide what we see on television. Okay, they're the people that decide what resolution that we see. They're the people that decide the content and how it's displayed. I apologize for those of you live that are hearing that little audio glitch. We're working on that. And then we have the DCI, the Digital Cinema Initiative. That's a newer group, right? SMPTE's been around for over 50 years. The DCI is new. You recall that just not too long ago, about 10 to 15 years ago, we started converting all the movie theaters from film to digital, and in doing that, there had to be a committee put together, which is the Digital Cinema Initiative. They decided what their standards were going to be. So SMPTE and DCI have two different 4K standards. So when you see 4K here live, the resolution you're seeing here is different than the 4K resolution you're going to see in a movie theater, all right? And so you need to understand what those differences are. So of course, we're all familiar with the old VGA resolution of 640 by 480. It made us all a lot of money in this industry, and also caused, for those of us who were using it in the early days, a lot of headaches, because it was so much easier to connect things before VGA came along, because there was only one signal type. But of course, VGA was totally new at the time, but it was much higher resolution than what we had before, which was CGA and EGA, for those of you who remember. And then of course came the next big revolution, I guess you would say. And again, we're talking about the big revolutions in our industry, because we had some incremental resolution changes, but the next big revolution came when we went to HD. And of course, there was an analog HD standard and a digital HD standard. You may remember that that we were pushing for a digital standard, and the rest of the world was pushing for an analog standard. So, as you know, full resolution, full HD is 1920 by 1080. I think everyone knows that and is aware of that, and that's a 16 by 9 aspect ratio. Well, there's also what's known as 2K resolution. So when you go to, how many of you go to movies at movie theaters, not just in your house? Okay, almost everybody does, right? Well, 90% of the time, that's what you're seeing in a movie theater, is what's known as 2K, which is not the same thing you're seeing in your house. 2K is slightly different. It's 2048 by 1080. So it's slightly wider. So it is not 16 by 9 aspect ratio, but it's actually 17 by 9 aspect ratio. So the screen is actually slightly wider than you have at home. So when we take a movie and convert it for home viewing, we're chopping off a little bit of horizontal information, which is not a big deal, right? But the fact of the matter is, it is two different resolutions. So it matters when you're using scaling technology and things like that, because do you want the monitor to decide what the resolution quality is going to be, or do you want another higher resolution, higher quality scaling device to discern that? Well, at 1080 resolution, when we're talking about small monitors, 60, 70, 80-inch displays, and even 100-inch displays, sometimes it's hard to even see the difference between a cheap scaler and an expensive scaler. But as we go up in resolution, it becomes more critical. And the next big resolution standard was Qxga, which is 2048 by 1536. A lot of laptops have this resolution, and also output 1080 as well as this resolution. And then we have WQXJ, which is 2560 by 1600. Again, a lot of higher-end laptops use these resolutions. This particular one is 16 by 10 resolution. This is a very common resolution used by Apple, for example, with the MacBook Pro and some of the higher-end MacBook laptops. And of course, Dell and some of the other manufacturers have also followed suit, because a lot of them are using the same graphic cards from the same graphic card manufacturers. And then we come out with 4K UHD. So remember, at the beginning, I put up 4K and UHD as interchangeable terms. Well, they're not totally interchangeable. When you see something labeled as 4K UHD, the resolution is 3840 by 2160. All right, so when it's labeled as UHD, the standard calls for, and that's the SMPTE 4K standard, okay, the SMPTE 4K standard, which was, again, SMPTE determines the standards for television for the most part. That resolution is 3840 by 2160. That is exactly what you're seeing here today. And I'll prove that to you by putting up some images that show you the difference in that and HD. Because when I'm putting up a Keynote slide, I'm using Apple Keynote, and I should also mention that within Keynote, to build this presentation, I actually natively built this presentation in 4K resolution. So this is not a scaled up presentation. I actually built this presentation natively in 4K. So I went into the Keynote master slide settings and put in a custom resolution of 3840 by 2160 because I knew that I'd be presenting this on a 4K device. You can do that. A lot of people don't know that Keynote and PowerPoint actually allow you to do 4K native displaying, which means that when I put in an image in it, I got to make sure the image is large enough or it's going to be dithered or look choppy or weird. So you're actually looking at a presentation that was actually originally designed at 4K and actually being displayed at 4K. So everything you'll see today is 4K. But the DCI standard, so the 4K that you'll see in movie theaters, and there's not very many 4K movie theaters out there. There happen to be 2 here in Dallas because you're a big city. But there aren't a whole lot of 4K movie theaters yet. But of course, they're all going to be rolling out over the next year or two. And a lot of them, a lot of different directors have different standards that they say we want our movies to first premiere in 4K. That DCI standard, again, is 17 by 9. So when you go to a movie theater and you see a 4K movie, you're going to see it at 4096 by 2160. So the horizontal resolution is slightly higher. Again, what does it matter? It matters because if your scaler or your switcher that has a scaler is only capable of 4K UHD, then the scaling quality of that 4K DCI is not going to be near the quality that you probably want in a professional AV installation, especially as we get to larger image sizes. Now granted, if the room that you're putting a 4K display in is only going to accommodate a 70 or 80 inch display, it may or may not even need a 4K display, you might think, because if resolution is the only thing you're thinking about, then of course that's logical. But if you're not thinking about all the other applications that 4K brings you, which we'll get into a little bit later in this presentation, not just resolution, you'll see that there is great value in using 4K, even in small displays. But the resolution doesn't become the key factor there. Other factors play a part. So you should at least know what those standards are. So again, there's 2 basic 4K standards, resolution-wise, and they aren't the same. And each manufacturer will tell you which one they are using. Right? Most of the manufacturers in our industry are going to use the 3840 by 2160 resolution. For example, Sony, who's also owned by a movie studio, they are using the 4096 by 2160. So if you have some displays that are Barco and some displays that are Sony, they're going to be using 2 different resolutions. So you have to have a product, a switcher, and with a scaler that actually outputs both resolutions when you're intermixing displays in the same system. And a lot of people don't realize that. So we're also have to deal with the refresh rate as well. And we'll talk about some of the issues with the refresh rate because sometimes you need a higher refresh rate, and a display and switching and routing equipment that handles a higher refresh rate is anywhere from 25 to 50% more money than a display or a signal routing and distribution equipment that only does 30 hertz. So 4K, 3840 by 2160, and here comes 8K. As you probably heard from the Olympics this past summer, a lot of original athletic events were captured in 8K resolution. A lot of the manufacturers over there were using that as a way to grab a super high resolution imaging for display purposes. So 8K will be still a few years off. We don't have to worry about 8K for probably a good 5 to 8 years before we actually start seeing even demo displays come out. So you'll see some products out there. You will see some products out there that are 8K that are more for demo purposes, but 4K right now is the thing that you need to be paying attention to, because all the manufacturers around the world that are building the raw components for projectors and monitors are all moving towards native 4K imagers, just like they all moved 10 years ago to 1080p. So it's a little bit frustrating that we don't have one standard, right? I mean, it is a little bit frustrating, but it is what it is, and that's one of the ways we as an industry have always helped our customers, is to help them understand the differences between the things that the sources have versus the things that the displays have. So I'm going to put up some 4K images here, and I want to show you certainly, I mean, we all know the value of 4K is high-resolution imaging, and these are actually images that were shot on it with a Canon 5D camera in 4K resolution. And you can actually see that as you move down the street here, and at 1080 you would not be able to read these signs. But you can see here in 4K we can actually still read the signage here and tell what's actually playing at these different theaters. So you can see that 4K, certainly from an image standpoint, image resolution standpoint, it just blows away HD. At HD, we'd be at 1/4 this resolution. Keep that in mind now. So if I put the same imaging up at this size of a screen and was only using a projector that could do 1080, we'd only see 1/4 of this resolution. So that is significantly higher resolution than what most of you are probably used to seeing. And it is just mind-boggling to me. It's just beautiful imaging that you get from a 4K display. I just like to sit here and watch them. Here's a video shot in 4K. So obviously, resolution-wise, we all get that. We're from the industry. We've been in the industry. We get the fact that resolution is a lot better in 4K. But that's not the real reason why 4K is going to be big in our industry. That's not the real value. Certainly in the consumer market, we know that they're going to be driven exclusively by the resolution. That's what the customers want. They see that's easy to grasp for them. It's easy for them to understand when they see or hear that it's 4 times the resolution of what they have now. But in our industry, we're not sort of that enamored with it just because of the resolution. But you're going to have to deal with it because you're going to put in display technologies where the native imager is 4K because the manufacturers that were making 1080 imaging products all moved to 4K imaging products. So there's not a single manufacturer in our industry that isn't retooling their manufacturing process for 4K. Everyone's going to 4K. So you're going to have to deal with 4K imaging. So in the TV and video market, 3840 by 2160. In the film and movie market, 4096 by 2160. And of course, we have to deal with the frames per second refresh rate issue. So thanks for the plethora of standards, but it is good for our industry because we're good at helping our customers understand and deal with these types of complexities. So that's one issue. So we've now dealt with the resolution issue. Now you know what resolutions are what and what came from our industry and what came from the digital cinema industry. But there's a lot more out there in 4K, and there's a lot of hype surrounding 4K, and you've probably seen at least a dozen or so manufacturers in the signal routing and cabling industry, for example, announce 4K products over the last 6 months, of which most of them, not some of them, but most of them are incapable of routing 4K at 60 frames per second at full color bit depth. And that's going to be a problem because when you put those systems in, so systems that you may have purchased over the last 6 months that were 4K capable, and then you start putting in new 4K resolution signals into them, they won't look that good. Or they start having problems, and you're not sure why. Because most of the stuff that has shipped so far is not capable of doing full 4K as we've been talking about it today. So here are the issues that you need to watch for and the things that you need to know that I'm going to help you to understand with regard to 4K. So we've got the resolution thing taken care of, which I've already talked about. You also need to understand the frame rate issues. And I'm going to explain that to you. I'm going to explain to you probably the most important thing of all in 4K, which you never had to worry about before, is chroma sampling. Okay, so there's this issue of chroma sampling rates that determines how good the color is, and that can throw everything off. The pixel clock, which you had to deal with, if you remember when we went from an analog standard to a digital standard, but probably didn't have to worry about as much as you will in 4K. And then the color bandwidth issue. So 4K, if you were paying attention, then you already know that, I kind of beat that up and told you about the different standards that are out there in 4K, and probably don't need to talk about that anymore. So let's talk about frame rate and chroma sampling. And the easiest way to do that is to explain exactly how a pixel works. Each individual pixel has basically a DNA, and in that DNA for that pixel, it tells the individual pixel on the screen exactly what color to be. And there's a formula for that to happen. So we're looking at an image here that has over almost 4,000 pixels going across. Each one of those pixels is receiving a signal of exactly what to do. Am I red? Am I green? Am I blue? Am I pink? Am I orange? Am I yellow? What am I supposed to do? And by the way, how fast am I supposed to turn on and off, and so on and so forth. This comes down to how good the product is in your system, and your system is only as good as its weakest link. I'm sure you've heard that before, but this should be important to be repeated. The system that you build a 4K with is only as good as the weakest link. So the weakest link in the product's ability to handle the frame rate and chroma sampling rate is going to determine how good the quality of the signal is. So here's what happens, and this is the terminology you'll see manufacturers use. And in a way, we've helped push that along, and I'll explain to you what I mean. We get a lot of press releases, a lot of product announcements as a publication on new 4K products and new AV products all the time, as you can imagine. I mean, that's the industry we're in. So for the first 3 or 4 months that that manufacturers were launching 4K products, they weren't specifying the chroma sampling rate. Almost no manufacturer was. They were sending us specs of products. This product is capable of 3840 by 2160, 4K at 60 hertz. And then I would write the manufacturer before we would publish it and say, what is the chroma sampling rate? And they would say, I don't know. And they'd say, well, let me go back and ask engineering. In almost every single case that's happened, they came back with the answer was 420. All right, so most of the products that have shipped so far from the AV industry for 4K are 420. What happens when you put in a 420 product in a 4K system where you're using full bandwidth, highest resolution color that you can get? Well, what happens is the DNA of a pixel, which in this case I've got a sample of 8 pixels, 4 horizontal times 2. When it gets translated with color information and the intensity information, right? So the chroma is the color information, and the intensity is the contrast ratio of each pixel, basically. Then what we get is a color summing, where we're approximating what it's supposed to be because we don't have the full bandwidth to exactly duplicate what it's supposed to be. So in the case where I send 444, I'm taking the color information and the luminance information, right, the intensity, and I'm putting it together and I'm generating 8 individual pixels that all have an identity of exactly what they're supposed to be. So when you're sending a 444 signal, meaning full color signal to 4K, and we only use a processor that only does 420, then I'm going to have a lot of color summing there. So you might think, well, what's the big deal? It depends on what you're displaying. If you're displaying PowerPoint slides, no big deal. I mean, look at what my PowerPoint slide looks like. It's mostly white information with some black text and some color information in there as well. But there's not a whole lot of specific detail. But if I start putting up more detail, or if I start putting up company logos, or if I start putting up motion images on there, then I start having some problems potentially, especially if the customer knows what the original source looked like. So one of the things you need to look out for is in the 4K spec is what is the chroma subsampling rate? Is it 444, meaning can it handle whatever color it is thrown at it, right? And we have 8-bit color, and we have 10-bit color, and we have more bit color coming as well. Right now, almost all the 4K products out there that have shipped so far are only capable of handling 4K 30 hertz 444, not 60 hertz. And at 60 hertz, they're only capable of handling 420, which means that if you stick a 60 hertz signal at it, you're going to chop off more than half of your color information. So if that doesn't matter to you, go right ahead. So if your customer's mostly using PowerPoint slides, mostly using Keynote type of stuff, that may not be a big deal. But when you start using fine detail information, they're going to start noticing things. So what does that actually look like? What will they notice? Well, if I were to take this is just the corner of a 4K screen. So if you can imagine a screen that's this large, and I actually just chopped off, maybe 10 inches of the screen, and I zoomed into it so I could see the details where I have a whole lot of text. So I'm going to blow that up for you, and this is what happens, is that as long as it's black and white information, we can read it. But when we start introducing color information, we can't read it any longer because I'm not able to correctly reproduce those colors on a 444 display if I didn't process it all the way through as 444. So depending on the information that you put on the screen, this could be a big deal. So what you need to do is look at the specification really carefully. So we stopped publishing 4K stories of new products in our publication unless they give us the chroma subsampling rate. So when you see a story published by us, it will always have the product's color sampling rate in there. So if you're not sure what it is, because most manufacturers aren't speccing it. When you go to their websites, they're not telling you what it is. If they don't tell you what it is, assume it's 420 or worse. Okay? Otherwise, go to our site, do a search on it, and see what we've published it as, because more and more manufacturers are now sending in that information. And again, it depends on what you're displaying. You don't always have to put in a system, for example, that does 60 hertz. Right? If you're only putting up PowerPoint information or only putting up slides like Excel spreadsheets and stuff, then you don't need a 60 hertz signal. So doing 30 hertz 444 is much easier and requires less bandwidth than 60 hertz 444. So you can see here at 1080, 60 hertz 444 required 148 megahertz pixel clock. And why does that matter? Because eventually this stuff is going to the network. As you know, the industry is going towards the network. So this is going to become a bigger and bigger issue. And of course, we have the bandwidth of all the switching products, the matrix switching products, the signal routing products, and oh, by the way, the cable. And I'll tell you how important the cable is. We have not yet been able to figure out how to drive this presentation where we are able to put the laptop up here on the podium and have the projector in the back there at 4K resolution. Why? Because nobody makes a cable that can do 4K, 444, 10-bit color, 60 hertz that allows me to drive that signal 100 feet. The only way we can do it is to convert it into fiber optics. So even though you're seeing manufacturers spec 4K cables that go 100 feet, you now know they don't actually go 100 feet, 444, 10-bit color. Something, they're trading off something, right? Because there isn't anything that exists. And in fact, HDMI, the HDMI standard doesn't even accommodate that yet, which we'll talk about in just a second. So when we get to 4K UHD at 60 hertz, 444, we need 594 megahertz of bandwidth. So we're not going to be able to send this through a standard network without doing some fancy stuff. So let's talk about color bandwidth, because the color bandwidth is the key to what things are going to look like. Because obviously we want, if I'm Coca-Cola, I want Coke Red to be Coke Red. I know what Coke Red is. If I'm Coke, I want Coca-Cola to have Coke Red. So how many of you are familiar with the term D65 or 6500 Kelvin? That's good. I'm impressed that about a third or fourth of you in here live know what that is. So that's the point at which we determined, as an industry, SMPTE determined that's the white point of images. So you know how we have, here in the United States, we use Fahrenheit to measure the outside temperature. Today, it's in the range of like 85 degrees Fahrenheit outside, right? And in the rest of the world, for the most part, they use Celsius, right? Which we all remember learning in school here in the US, that you like add 32, like you multiply it times 2 and add 32 or something. There's some kind of formula that kind of gets you approximately there to go from Celsius to Fahrenheit. But there's also a color temperature scale known as Kelvin. That determines the color temperature. D65 is what the industry in the 50s determined was the white point for television. So when something's going to be white, it's going to be 6500 Kelvin. So the issue here is how much color bit depth are we dealing with, and what can we actually display? And this is key because in the world of 4K, we have the ability to display way more colors than we could have in the world of HD with the projection technology we have had so far, for example. So when I'm talking about going from 1080p, which you're all familiar with, at 8-bit color, I'm required to use 4.4 gigabits. At 10-bit color, I'm 10 gigabits. Now, what does that mean? That means if you have seen a product debut that sends video over the network, you know, if it's a standard network, that must be a significantly compressed signal to send 1080p across the network, right? Does that make sense to everybody? Because a standard network is not 1 gigabit. That's not a standard network. It is what we know is, you know, 100-bit Ethernet network, right? 100 megabit Ethernet network. So if I'm going to send 1080p across the network at 10-bit color, full color, right, which is the maximum color we can get right now, I'm going to require a larger network than even a 10 gigabit network. So now imagine what happens when I send a 4K UHD 60 hertz 444 signal across the network. I'm going to require at 8-bit color a 17 gigabit network, and at 10-bit color a 22 gigabit network, which means now I'm going to have to use a 100 gig network. So for us to go video over IP with 4K at full 10-bit, we're going to be looking at a totally different network scheme than we're doing now. So this is just to give you a reference as to where we're moving, because the industry is moving that direction. Now, right now, all the 4K signals that you see from laptops, from source material like videos and movies and stuff like that, are all either 8-bit color or 10-bit color. So if you want to build a system that can do full bandwidth color, then you're going to have to build a system that's capable of doing 10-bit color, right? Because 10-bit color is going to have significantly more colors than 8-bit color. But we're going to require a very large network. So let's zoom out and let's put this into perspective. So there's all the colors in the CIE color curve. So that D65, that middle point right there, that is white. And as you know, white is between red, green, and blue, right? What's white? White is 100% red, 100% green, 100% blue is white. 0% red, 0% green, and 0% blue is black, okay? So the difference between the white and the black is our contrast ratio. How many steps we have between white and black is our contrast ratio. So when you see projector manufacturers spec our contrast ratio, that's what they're specing, how many steps. So the quality of our contrast ratio, the difference between white, which is 100% red, 100% green, 100% blue, and black, which is 0% red, 0% green, 0% blue, is our color bit depth, is the quality of our colors. So if we're compressing that, the colors get compressed too. So in the world of projection, up to this point, before laser projection, the most colors we were getting in projection of anything that we were doing in our world of boardroom, classroom, training room, classroom, is that black line right there. Do you see that black line? That black triangle? Of all the colors in the CIE color curve, that's how many of them we were capturing. So look how many colors we were never even showing. And you know this, right? A customer would have a laptop and the colors wouldn't look the same. It would look close, but not the same. Or you go out and take a picture with your iPhone and then you put it on a projector and it doesn't look the same as it did in real life, right? Because the human eye can see a whole lot more colors than what we can display. But this projector we're using here is a laser projector, and see that white line? In 4K, 10-bit color, that's what we're capturing. So one huge benefit of 4K is not just the resolution, but the color bandwidth is huge, especially when you're dealing with a technology like laser, where we have a much better white point than we would in metal halide projection or a lot of the other projection technology we've used over the years. So we're going to capture a whole lot more color capability. So we're going to want, so what's going to happen, I want you to understand, this is a byproduct. Because we're using laser projection and now we have the ability to reproduce more color, our signals now have the need to have the ability to process more color. Because if we have a projection technology that can now grab this much color, why would we feed it just the stuff that's inside the black triangle? So that what happens is, if you have a 4K ready system now, it's capable of doing what's in the black triangle, but you've got a projection system that's capable of doing what's in the white triangle. So you're basically chopping everything up and squeezing it into a smaller tube. So that's why when you're speccing 4K, you should be looking at the capability of what you're able to do with these new projection technologies. Now, granted, there will be some projection that will come out that is still metal halide 4K. You don't need to worry about it, because even though you're processing some awesome colors, the projection technology can't even show them to you anyway. So you might as well not worry about it there. So there'll be like low end, entry level, there'll be mid-range, and there'll be high end. And you'll see all that the mid-range and high end will be solid state technology, like LED and laser, that have a capability of doing higher color bit depth. Does this make sense to everybody? Okay, so and you sort of have to somewhat educate yourself, because I only have an hour and 15 minutes, so I can't really kind of go through and tell you everything. So I'm trying to give you the highlights of the specs to look for so that you can sort of educate yourself as you go on. Of course, I've written a lot of articles about this on our website at ravepubs.com, and also we've had a number of writers that are experts in the 4K world write a number of articles that are on there as well. So color bandwidth is something that we have to pay attention to now. And now we have even higher resolution projectors and higher bandwidth projectors that are even capable of doing even more because of the new laser technology and solid state lighting technology. But then there's this other thing. How many of you are familiar with the term HDR? So halfway through, meaning we've had press releases for about the last 7, 8, 9 months on 4K products. About halfway through, all these manufacturers, and I'm talking about everybody, all the projector manufacturers, all the signal routing and distribution companies that you could think of, the Kramers, the Extrons, the Crustrons, AMXs, all of these companies. About halfway through, all of a sudden, they started sticking the term HDR on there. Because what happened was everybody was like, wait a minute, we can not only do 4K and high color bit depth color there, we can also do it with HDR. We can actually get even better color. Now, you're probably familiar with HDR because, as you know, the iPhone has an HDR on and off mode, okay? So that's high dynamic range, which the best way for me to explain this to you is to show it to you. That's the easiest thing for me to do. So the image on the left is no HDR. The image on the right is HDR. So all we've done is take the same camera, and this was an iPhone, and taken a 4K image with an iPhone and turned HDR off on the left and on the right. All right? So you can see that both of them are awesome images, but the one on the right, you can see a higher color bit depth. And in case you can't see that because of the contrast ratio of the room, let me try this. Same camera, Canon D5, 4K, set up exactly the same way, same camera, picture taken 1 minute apart, no HDR on the left, HDR on the right. That's the only difference. There's no photoshopping of this being done or anything. All I've done was take the image and put it, the one on the left is no HDR, one on the right, HDR. Do you see the difference? So now, in addition to looking at all these other specs, you should look and see if it's capable of HDR as well, which most of the new 4K stuff is capable of HDR. So now let's talk about that pipeline, because that's going to be a key factor, right? How are we going to connect all this stuff together? In building systems that are 4K, obviously in our world, connecting them together is the key there. And we have 4 connection standards that exist right now that are capable of doing 4K. You can't do 4K with a VGA connector. You can't do 4K with BNC connectors. There's nothing out there like that that does 4K right now. So all the standards allow for either HDMI DisplayPort, mini DisplayPort, or SDI. In our discussions for today, mini DisplayPort and DisplayPort mean the same thing, because the only difference in mini DisplayPort and DisplayPort is the connector itself. So for example, Apple, when they put DisplayPort on their laptops, they use mini DisplayPort to use less real estate, right? But a lot of the monitors, like this monitor here, has a actual DisplayPort input, not a mini DisplayPort input. So we use a connector or a cable, and the projector that we have back there also has, the Barco HDX also has a DisplayPort input in addition to an HDMI input. Now we're all familiar with HDMI, right? I mean, everything HD is HDMI. Don't we just love the HDMI connector? Yeah, we love that connector. But the fact of the matter is we're going to have to deal with that even in the future, because we have the consumer and the professional standards rolling at the exact same time. Like, we're the professional side of that, and the consumer side is, the Best Buy kind of industry and home theater industry. All right, so we have to look at, in signal routing and distribution, we have to look at what the source is and what kind of distribution capabilities do we need. If we're doing full bandwidth, full color, 444, right, all of our equipment that we specify needs to be capable of doing that, because again, the system is only as good as its weakest link. Here's a little statistic. Anybody here go out and buy a 4K monitor for their house yet? Anybody bought a 4K TV? Okay, that's good, cool. Your TV is only capable of doing 420. They haven't shipped 444 TVs yet. What's interesting is they have a spec on the TV that says it's 444, but inside the TV, they're converting the 444 coming in to 420. You're actually only displaying 420. So we're doing a lot of color summing. Granted, the resolution is a lot higher, but the color is no different than what you were looking at before. So you got a higher resolution image with still less color. So what you will see is, as manufacturers start speccing 4K with HDR or 4K 444 in the consumer world, you'll see another set of TVs come out that are 4K, capable of doing full color, not converting it down to 420. So there's a couple of different ways that we can send 4K right now. That seems odd, but that's just the way it works, because we're dealing with a very high resolution image. We're dealing with an image that is literally 4 times the bandwidth of HD, which is what you're familiar with. One is And these images are thanks to Extron for allowing us to use these images in this presentation today. They have a white paper on 4K that they had these images in. One way is to take a 4K image and chop it into 4 1080p images and send it down 4 HDMI cables. I know that sounds crazy, but the problem is the HDMI LLC, the people who govern the governing body for HDMI, there is no such thing as a 4K standard to send 4K down one cable at 10-bit color 444. So you can't just do it in one cable. You have to use multiple cables. So if I'm using HDMI, that's how I have to do it. So one way is to use a signal processing device that chops it into 4 images, sort of like a video wall processor, right? Of course, that may be an expensive way to do it. It may be inexpensive depending on, what you're trying to do with the signal there. Another way is to chop it in half. So turn it vertically and chop it into 2 2160 by 1920 images, and then I can send it down 2 HDMI cables, which is how most full bandwidth 4K signals are sent now. Whether it's internal in the product, right? If they're not doing fiber optics, this is what they're doing now. They're chopping it into 2 different images. But if you want to send it down one cable path, you can do that with HDMI or DisplayPort. But in the HDMI world, you can't do that with 10-bit color. So if you have a source that is 10-bit color, you have a customer with 10-bit color stuff that was generated, like a graphic design firm, an advertising firm, a science company that's doing science visual imaging, a school that teaches those or is in the sciences that have 10-bit color images, you can't use HDMI. You're going to have to do your signal routing with either fiber, right, which will probably use DisplayPort connectors from the sources, but you can't do it with HDMI if it's 10-bit color. You can do it in 8-bit color, so you can send an 8-bit 444 4K 60 hertz signal down one HDMI cable, but then if we go to 10-bit color, which, by the way, when I go from 8-bit to 10-bit, am I only getting a 20% increase in color? No, I'm getting a significantly higher. What is the percentage? Who can tell me? Yeah, exactly. So we're talking about a bandwidth of this versus this in color. So I'm going to have to use DisplayPort, right? So if I want to do one cable DisplayPort, that's the problem with putting my laptop here, because I can't send DisplayPort 100 feet like that. I'm going to have to convert that DisplayPort to fiber and then back to DisplayPort on the other end. So you should be aware of that. So the current standard for HDMI allows you to do all this, right? But when I get down to HDMI 2.0, 21 gigabits per second. Remember, if we go to a network, because we're going to see a lot of products come out now that are AV over IP. That's the next big thing you're going to see every manufacturer push, AV over IP. Check the bandwidth, because if it isn't at least a 100 gigabit network, they're compressing it. There's no such thing as uncompressed down a 10 gig network for 4K. It's definitely compressed. So even though the manufacturers say it's not compressed, or they'll say lossless compression, which that actually means nothing. There's no such thing as lossless compression, because if there was, everybody would be doing it. When you compress something, you obviously lose something. So HDMI 2.0B, 21 gigabits per second, 444 60 hertz, one cable 10-bit at 30 hertz, but at 60 hertz, we have to use 2 cables. So if I'm going 30 hertz, I can use 1 cable. For my refresh, what's the difference in a refresh rate of 30 hertz and 60 hertz? Well, in the world of video, that's flicker or no flicker, right? We all know that from the years ago, when we went from, dealing with all the refresh rates back in the day when we had 43 hertz refresh rate with VGA. Do you remember that with IBM PS2 and all that kind of stuff? So for those who have been in the industry a while, understand that. So right now, the HDMI standard doesn't even accommodate a single one cable. There is talk in the HDMI Alliance to come up with a way to do it, but that would mean what? That would mean you have to go out and buy all new HDMI cables for your system when that actually happens, but obviously it's not in the pipeline right now, which means that they're just now, at best, they're just now talking about it, which means they got to talk about it, and then they got to adopt it, and then they got to publish it, and then everyone has to build product for it. So we're still a year or two away from that. If I do DisplayPort, however, I can do DisplayPort 1.2, 444, 10-bit at 30 hertz, or 10-bit at 60 hertz with 1 cable. But again, there's a distance limitation with DisplayPort. So I can't go build a system in a conference room and just be routing the heck out of everything in DisplayPort without paying attention to the distance limitation of DisplayPort, which is easy to find. Just go to Wikipedia and look at it, and it tells you all sorts of things there about it. And you can go to Extron's website, you can go to Kramer's website, go to Crestron AMX's web. They're all publishing stuff on what the distance limitations is in DisplayPort, as well as most of the projector manufacturers. SDI for live events type stuff. For those of you who are doing live events, that matters to you. We would have to use 4 cables for 10-bit color. So it's not as simple as just connecting up an HDMI cable and routing it through your source. You're going to see manufacturers are going to have to take very careful concern with signal routing and distribution of 4K, because we're talking about sending 4 times the amount of material and the amount of bandwidth, the amount of content down the pipeline that we were before with HD. So to future-proof your systems, don't just look at you need to really ask your customers basically what the application is, or really understand the customer's application. Because if it's just video and it's not high-resolution video, meaning I'm a classroom and I'm just downloading videos off YouTube and I'm showing them to my class of 9th graders, and every once in a while I'll show science stuff, and every once in a while I'm showing my keynote or PowerPoint slides, 4K 60 or 30 hertz is all I need. So you're going to be in the situation that you were never been in before, and that is deciding what refresh rate to use based on the application. Whereas before, everything worked at 60 hertz, so that wasn't a big deal. And in fact, the only thing we had to worry about before was whether I'm going to go 720p or 1080p. Remember those days, right? But now you're going to look at refresh rate. Why? Because a signal routing product like a switcher that does 30 hertz will cost half the price as one that does 60 hertz in many cases. And then that doesn't include all the cable and everything else in the system and the projector itself, which will cost less. Right now, full band projectors that do 10-bit 4K are $30,000 to $50,000 to $70,000. The ones that do 8-bit 30 hertz are $4,000. So we're talking about a huge range in pricing for those projectors. Now again, the brightness makes a difference as well, right? We haven't even talked about the brightness. Of course, the brighter a projector, the more expensive it is, because we have a higher lumens output. So I want to talk about the applications of 4K in the Pro AV world that go beyond resolution. One of the most common questions I get, and we've probably already had it online, I'm sure, is at what point in time should I put in 4K? At what point in time, like the gentleman who raised their hand out here that have a 4K monitor, at what size would you need 4K in your house? The rule of thumb the industry is saying is 70 inches and above. So if you're putting in anything 70 inches or below, or I should say above 70 inches, if you're putting it in something that's below 70 inches diagonally, then they're saying you're not going to notice anything. So if I take a 1080 monitor and put it in my house, a TV, and put it next to a 4K monitor, at 70 inches I'm not going to see a difference. And they are absolutely correct, except that only applies to resolution. It does not apply to color bit and color bandwidth. And it also doesn't apply, it also is also, you have to take into consideration what's being displayed on there. So if it's just watching TV and you're streaming, I don't know what you're using, but I assume you're streaming something 4K from Netflix or something like that, right? Well, I can guarantee you that Netflix is giving you the smallest bandwidth possible. At best, they obviously aren't sending you a 10 gigabit pipe. You're doing it over your standard, 20 or 30 megabit internet connection, so you're getting higher resolution, but the color bit coming across that pipe is so crushed anyway, it doesn't do you any good to buy a full bandwidth, full resolution monitor at this point in time, because we don't have any sources that can supply it until we have physical sources like Blu-ray and stuff, 4K Blu-ray and stuff like that. So what are the applications of 4K? And this is where you're going to make all your money. This is where the future of our industry is. 4K is a huge. I can guarantee you, and I have no doubt in this statement at all, in that if we look back on this year and next year, 10 years from today, we will say that this was the biggest revolution in display that our industry's ever had. Nothing that came before now will have a big of an impact on our industry as switching to 4K did, even bigger than 1080, and you'll see why in just a moment. It's because of course, we're going to get awesome imaging in 4K, no question. 4K is stunning, and it really is 3D without the glasses. The nice thing about 4K is you don't have to have 3D glasses on because it looks like you're looking out a window, right? Certainly comparable to what we had before. When you compare it with HD, it is significantly higher resolution. So in the world of higher resolution imaging, just because it's higher resolution, like the home, that's a guarantee. That's okay, obviously, that's going to sell really well in the home. And that's what people are going to go after. That's going to be the low-hanging fruit, is upgrading everything in the home. But in the boardroom market, what 4K brings us is significant. And that is, it allows us to do multi-imaging in its native resolution format. So what you're going to see is in boardrooms and conference rooms and training rooms, the fact that you can do video wall type stuff with one display. So instead of putting in multiple displays to do video walls or put up multiple images, you'll be able to do it with one display. So what you'll see is rooms like this, where you'll have a single display and you're chopping the image into 4 full resolution HD displays. So, for example, how many of you have heard of the Barco ClickShare product? Raise your hand. Okay. We all know what that does, right? It takes 4 images in and allows you to display 4 images on the screen at the same time, right? We're familiar with that? However, the output resolution of the ClickShare is 1080. So it's taking the 4 images that you have coming in and scaling them to a much lower resolution. But the 4K version of this will blow you away, because then you take the images coming in and you're not scaling them at all. So your PowerPoint presentation is now in full resolution. Your video that you're playing is now in full resolution. And not only do we just keep them in a 2x2 wall configuration, but now we can move them around and do whatever we want with them because it's one giant palette. So we can scale the windows to be as big as we want. So in some of these applications, it's obvious. And this is going to be an easy sell. So as Barco comes out with a 4K version of ClickShare, it's going to be hugely popular, as will all those manufacturers that have collaboration systems in the 4K domain will be very, very popular, because it allows you to put up 4 1080. So this is what you're looking at, is 4 1080p resolution images simultaneously. We're not reducing the resolution at all. So my customer is seeing exactly what they originally intended for you to see. But let's talk about the digital canvas. And this is the future of our industry. There's no question in my mind. As I said, look back 10 years from now, this is going to be the biggest, most significant develop in the Pro AV market that we've seen so far. So in the digital canvas, imagine this. Instead of you speccing a projector based on the least favored viewer, every room up till now has been specced based on the least favored viewer. So we determine the screen size based on where the least favored viewer is sitting, and we look at a formula like 6 times or 1/6 that height. So if that person is sitting, 15 feet away or say 30 feet away, then we're going to go screen height's got to be at least 1/6 of that, so that we can get the image large enough that the person in the back right-hand corner can see the image. Throw all that out the window in 4K. Because in 4K, what I can do now is I can project the entire wall. I can turn the wall into a giant digital canvas, and I can put all my images up in native resolution of what they were intended to be. So in building a classroom, you would have put in, let's imagine the average classroom, where we have a classroom of maybe 30 students or maybe 40 students. And we would have put in a 110-inch diagonal image, right? And they would have had their keynote slides or PowerPoint slides blow up on that image, and they might have a screen that, and that's what we're mostly presenting on. But instead of putting in a screen that's only a 100-inch diagonal, why not just project on the entire wall in the front of the room and still put the PowerPoint slide in that same size? So the least favored viewer still required a 110-inch diagonal screen. So every time I put up PowerPoint, I'm putting it up on 110 inches diagonal, but also I'm projecting clocks up there. I'm projecting the Twitter feed of the class. I'm also projecting whenever I bring up video content, or even better than that, I can project my previous slides, because you sometimes are in a meeting with a presenter where the current slide, they're moving so fast that you can't write down the notes from the previous slide. So I have the current slide up in its native size that my systems designer would have spec'd, right? Right now what happens is you send a systems designer out, they look at the room, they tell you how big the screen needs to be, and you design everything around that. Forget that. Project the entire room as one giant digital canvas and put up whatever I want, but make sure the primary image is the size that the systems designer would have originally specified for the screen. And here's the cool thing. Now, like this projector we have back here, now granted, we're at the very beginning of this. So yes, this is an expensive projector, but we all know what happens with all these projection technologies. Let's fast forward only 18 months from today. We're using laser projection in all these 4K products. Guess what you can do with laser? You can tell it to take out the color of the wall. So I don't have to have a white wall. I can project on any color of wall I want. The color bandwidth of laser means that I can program in and take out the color of the wall. Now granted, you can't do it on a dark wall. You're going to have somewhat of a light wall, but if it's gray, if it's off-white, I can actually program in to take that out, and I can remove that color from the image because the wall is going to create that color and still get a color-accurate projected image. Not perfect, right? But if everything had to be perfect, no one would be walking around with a cell phone. Remember I said that. If everything had to be perfect, no one would be walking around with a cell phone. My teenage daughter watches most of her television on this. If I would have told the high-end home theater market that this is going to be the device that the future millennials will be watching most of, not all, not some, but most of their images on, 10 years ago, they would have thought I was nuts. So forget about perfect systems design and give your customers this digital canvas option where you can project the entire front of a room and design whatever you want to design. So in a large classroom environment, you may require 2 4K projectors, right? Or in a boardroom application, 1 4K projector. In fact, in this case, we can actually image map out the door. Because, by the way, all these laser projectors have image mapping in them now. So I'm now projecting the entire room. That area that says current slide is the size of the screen we would have normally put in the room. So we would have just had a wall for the rest of the room. So let's project the whole wall and use it. Let's use it for whatever else the customer wants. Why put up an analog clock when we can put up a digital clock, and we can also put up whatever else the customer wants. And, oh, by the way, let's talk about turning this into a touch surface. Let's talk about adding additional content to it. This is going to take our industry in many different directions. You will see signal routing and distribution companies coming out with signal processing products that deal with this kind of stuff, because this digital canvas concept is going to be big. We could not have done this in 1080. Why? Because if I project the whole wall in 1080, my PowerPoint slide is only 640 by 480 at best. That would have been, everything would have looked dithered. It would not have looked good. But in the 4K realm, now I'm 4 times that resolution. My PowerPoint slide is in the same resolution it was originally generated in. I can promise you this. If you don't tell your customers this exists, I can guarantee you they won't buy it from you. I'll repeat that. If you don't tell your customers this exists, I can guarantee you they won't buy it from you. So try this out. And we've been doing this presentation now 4 times around the country, and we're going to continue to do it as 4K becomes adopted. And I'm constantly getting emails from customers like you, integrators, asking me questions about whose processing products do this or that. And they're all saying, my customers love this idea. We just have to figure out exactly how to integrate it into their particular room, because they're not used to the concept of being able to stand anywhere. They're used to having this be the area where the instructor stands, this be the area where the screen is, and they have to be careful of where they stand. But now in the 4K world, with short throw imaging, I can put the projector right up against the wall. I mean, I won't mention the names, but there's 2 manufacturers that have 4K projectors, 2200 ANSI lumens, that are 8 inches off the wall. And the 8 inches off the wall can produce a 130-inch diagonal image. 11 inches off the wall, 130-inch diagonal image. So it's only going to get better from that. I can hang the projector even a little further off the wall and fill the room. But again, if you don't tell your customers this exists, they're not going to buy it from you. This digital canvas concept will be big because we now have the pixels to fill the wall that we did not have before. Does that make sense to everybody? I see a lot of shaking heads, shaking yes. That's exciting that you like this idea. So now we have time for questions, I believe. I thought my question mark would come up, but yes, there it goes. So we have a little bit of time for questions here in case we have anybody who wants some clarification or concerns about anything I've talked about. Any questions? Yes, Ron? Right, so that's a good question. So this digital canvas idea, what does that say for the projection screen? Well, I think the screen manufacturer is going to have to get creative, and they're going to have to look at immersion environments. And all of them have worked on immersive environments in the home market. That's been a big thing. Where the home theater industry has moved over the last couple of years, has gone from rooms designed with formula to IMAX environments, right? If you look at the typical home theater design now, they're immersing you in IMAX environments. Why weren't they doing that before? Because everyone was putting in 720p projectors. And when you blow up a 720p projector, all you see is a whole bunch of little teeny squares, right? You start seeing the imaging devices. But here I'm looking at 4K, and I would encourage you to come up to this at the end of the presentation because I'll leave this on. But when I walk up to the screen, it's not until I get about here that I even start seeing the little pixels, the squares. This is not a normal viewing distance. Certainly out here would be more of a normal viewing distance, and you see nothing but a digital image. So the screen manufacturers are going to get more creative, and as you know, all the screen manufacturers have moved to all have as an option paint, and you're going to see more screen paint surfaces that will debut in the future because they're all very aware of this. Again, it was not an issue before because we didn't have the imaging capabilities to do this, but as we now get into high resolution imaging, that's going to be a bigger deal. It's a good question. Any other questions? Yes, sir, go ahead and back. Okay, question is, will 4K include smartboards? Yes. Every single projector manufacturer, let me back up. There are only a handful of raw material component manufacturers in the world making raw components for projectors and monitors for that matter. So even though there's 25 or 30 projector manufacturers, there's 5 companies feeding all of those companies. You're aware of that, right? There's only a couple LCD manufacturers, and there's only one DLP manufacturer, as you know, right? TI, and they're here in Texas. All of them are moving their production lines to 4K. Therefore, that doesn't mean they won't make the lower resolution stuff, but that's what they're ramping up for. So that means all projectors. It'll go top down though. First the big expensive products, then the meeting room products, then the portable products, then the Pico products. So 2 years from today we'll have a full lineup. A year from today you're going to have large venue, auditorium, and conference and meeting room will all be shipping. Most of the large venue and large conference room projectors start shipping this fall from all the manufacturers I've mentioned so far. And you had your hand up, sir? I believe your question was, is there any future tie to this in virtual reality and augmented reality? Of course. I mean, if you think about this in immersive environments, we now have the ability to immerse in especially augmented reality, right? Because in the virtual reality environment, the reason why you put headsets on, and this is a key element, the reason why they have you put a headset on is to immerse you in the resolution that fills your frame of view, your frame of reference, right? That's why they put that on your face. If I can then build that as an element into an environment where I'm not putting it up against your face, but moving you into an environment, then absolutely. In fact, all flight simulation and simulation companies are now all speccing 4K. I mean, no one is going back to 1080 when it comes to high-end simulation, image magnification, all the future concert venues. When you see every major band that's going out and doing a tour next year, they're all speccing 4K or equivalent or even larger LED that makes up a resolution even higher than 4K because no one wants to have the limitation of what the pixels are going to be able to give us. This literally quadruples our resolution on the same imaging format instantaneously. So yeah, augmented reality, this is a no-brainer. In virtual reality, we're still going to see headset environments until we move away from we're able to build like cave kind of environments like that are curved and you don't have any seams, right? That's the issue there. Augmented, we're not worried about seams. In virtual reality, we're worried about seams, right? So they're sort of two different things. But of course, 4K is going to be big there as well. Yes, sir. Well, not just 4K. All projectors can do that. In fact, there are projector companies now that ship. Epson has projectors that do this. Barco has projectors that do this, where you can program in to take out color. And in the world of laser, because our color bit depth and our range of color is so much higher, we can get more accurately remove those colors. Yes. Exactly. You're exactly right. If it's a textured surface, that's going to be impossible. Other than if it's all the same color, but then I have physical elements, I can image map those physical elements so that they'll still be in focus, and that's built into all these projectors. All these 4K projectors are coming out with image mapping, so you can do that. But yes, you're exactly right. The wall would have to be the same color, so you'd have to encourage your customer to repaint that wall. And I think what will happen is when you start talking to your customers about this, it'll be a no-brainer for them. Just paint the wall white, whatever color temperature you want it to be, and you're going to find that color temperature available from whatever screen manufacturer has it available that you use. And I mean, obviously, Daylight is a big manufacturer, and they already have that. So there was another hand up over here as well. Yes, sir. It's a good question. Will dedicated fiber be the only solution for streaming across campus? I mean, with these types of bandwidths, all the manufacturers that I've spoken to, which are all the high-end signal routing and distribution companies, are all focused on fiber. You're absolutely correct. They're all focused on fiber. They also recognize that campuses don't always need perfect imaging everywhere, so there's going to be AV over IP where it's okay. Like in a journalism school classroom, you don't need to have uncompressed 4K imaging in the typical classroom. But in biology and chemistry and in the graphic design department and things, in the architectural world, you do. So it depends on the application. So I think what you're going to see is what you're seeing from most of these manufacturers is a wide range of products. Some that are slightly compressed, right, that are high bandwidth, some that are medium compressed, and then some that are totally uncompressed. When they're totally uncompressed, they're going to go across fiber. I think that's what you're mostly going to see. And we have a few online questions, it looks like. Yep. Aside from the digital canvas concept, what advice do you have for selling customers on because of the increased cost of 4K? The higher resolution imaging and the fact that it is a new technology, the byproduct of that is always cost is more expensive. But what's interesting about this is that 4K, this new generation of 4K imaging that's coming out, is interestingly enough at the same price point that 1080p was 6-8 years ago when it first started becoming the standard. So we're not blowing the walls off on pricing. If you recall, when 1080p, many of you may even remember this, when you went to Best Buy and bought your first HD monitor, you paid $2,000 to $4,000 for it. Now you go in there $300 to $500. Same thing in the world of projection. 4K, the lowest price 4K projector that is native 4K is about $11,000, and then it goes on up from there. It's the same way with 1080p. We had 720p projectors that were $5,000 to $6,000. We had 1080p that were $10,000 to $15,000. 4K is in that same range. So you're going to see all that stuff go down. So if the customer is first and foremost price sensitive, then I would hold back a couple of years. If the customer is image quality sensitive or wants to make sure that they're future proof, then I would sell that on the fact that you are future proofing a system. And we all have upgrade cycles, and this is an interesting one because if your customer's in the middle of an upgrade cycle, this would be the time to obviously sell them on future proof, because by the time the next cycle comes around, everything will be 4K. So if their only issue is price, then you may not be able to sell them. But if that's only one of many issues that's important to them, then I think it will be okay to do. And we had a hand here. David, go ahead. Uh-huh. Yeah, you're paying more up front because you don't have to change lamps. Right. Yeah, in reality. Yeah, David's question is that now projector manufacturers are able to charge more because it's new, and there's a total cost of ownership advantage by the fact that you're not having to change lamps every year or 2 or 3 depending on the application. But how long will manufacturers be able to sustain that using that argument? And I would say not very long. I think what's going to happen is, unlike any other time in the projection, you have sort of a perfect storm. We have a standardization of a new resolution of 4K, and we also have manufacturing techniques like we've never seen before. Remember when we had our last revolutionary resolution change, not only did we change resolutions, we went from analog to digital. That required a special manufacturer that could do both at the same time, because we went from everything being analog to digital to everything being 1080p and 720p. Everybody's already ramped up the analog to digital. We're already there. Now all we're doing is changing resolution. So what you're going to see is you're going to see a lot of competition from overseas to the current competition that we have here, and you're going to have the perfect storm where you're going to no longer have 5 raw component manufacturers, but more like 10. So we already see it coming from Korea and China as well. So I'll stick around for a few hours. Thanks to those of you who joined us online for this live stream. This also, for those of you who are live and are on live stream, this will be made available online forever. We'll put it on our website, and you'll be able to watch it on YouTube and on Facebook Live. And you can, for those of you who are watching online, there'll be a link posted in just a minute where you can take the test and get the Infocom CTS credits. And for those of you who are live, you automatically get them because you sat through it live. Just make sure, as long as they scanned your badge when you walk in the room, you're going to get them. Thank you very much for your time and attention.